Welcome to the course Depreciation, Alternate Investment and Profitability Analysis. We are continuing with module 2, which is alternative investment. In this lecture, I will discuss one of the alternative investment methods, that is present worth method. In finance, the net present value or net present worth of a prospective series of future money receipts is the present investment that the future receipt would just repay with interest, or it can be simply defined as the present value of cash inflows minus the present value of cash outflows, that is the net benefit to the organization. Economic studies for choosing between alternate projects and investments can thus also be made by comparing the present worth of the future of the funds necessary to endow service for a given number of years, when the goal is to increase the value of the wealth. In the annual cost method, we have converted the money time series to an equivalent uniform annual cost, whereas in the present worth method we shall convert the money time series to an equivalent single payment at some specific date. The basic advantage of net present worth method is that it considers the time value of money. The disadvantage is that it is more complex than other methods that do not consider present value of cash flow. Furthermore, it assumes immediate reinvestment of the cash generated by investment projects, and that the inflow of cash other than the initial investment occur at the end of each period. This supposition may not always be reasonable due to altering economic environment. Now, the formula which we will be using in this lecture are, now if I want to convert A to P, that means a range of annuities to the present worth, then my formula is P is equal to A, P by A I n is equal to P into 1 plus I to the power n minus 1 divided by I 1 plus I to the power n, or this factor can be simplified by writing 1 minus 1 plus I to the power minus n divided by I. So, the annuity, this A is annuity here, the present worth of the annuity, sorry this is not P, this is A. The present worth of annuity can be calculated like this, and then the present value of a future value is computed like this. So, we will be extensively using these two formulas in this lecture. Now, we take up the example 1, and the objective of example 1 is, given the capital investment, 0 salvage value, equal estimated lifespans, different annual operating cost, compare two different investments based on present worth method for a given attractive rate of interest. The example 1 is, for floor cleaning you have two different machines, machine B and machine C. Machine B costs 80,000 rupees and expected life is 8 years. Salvage value is 0. Operating cost $600, whereas the machine C costs 55,000. Expected life is 8 years, salvage value is 0 and annual operating cost is 1000. If the attractive rate of return is 10%, then which machine is most beneficial to the company? Use present worth method to justify your results. So, this is our question and let us solve it. Now, the costs are basically put in 0 line. That means, for machine A, B at t equal to 0, I will invest rupees 80,000. Similarly, for machine B at t equal to 0, I have to invest 55,000. Now, this 600 has to be, this is basically annuity, and for 80 years the 600 rupees will be paid. That means t equal to 0, t equal to 1, 600, t, sorry, this is 1, 2, this is again 600, 3 again 600, up to 8th year again 600 will be paid. Now, to find out the present value of the 600, this is an annuity, every 600 has to be brought to the 0 line. So, by using the annuity formula, the present worth for machine A, sorry, for machine B, this annuity, the present worth of operating cost is equal to 600 into 1 minus 1 plus I to the power minus 8 divided by I. And this is the formula we have used. I had already told you this formula is derived from here, A 1 minus 1 plus I to the power n divided by I. Now, if you compute this value, where I is 10%, then this value comes out to be rupees 3200.96. So, the total present worth is this value plus this value. So, this is 80,000 plus 3200.96, that comes out to be 83,200.96. So, this is the total present worth of machine B. Similarly, we can compute for machine C for machine C. Please note that this is already the present worth, this is already the present worth, only you have to convert this value to its present worth and add it up. So, present worth of machine C is equal to 55,000, because the cost will be spent at time t equal to 0, and present worth of operating cost is equal to 1000 into 1 minus 1 plus I to the power minus 8 divided by I, and this comes out to be 5334.93. So, present worth of machine B is 55,000 plus 5334.93, which comes out to be 6334.93. As the present worth of the machine C is less, this is less, it is preferred. Now, the objective 2 for this example is, given the capital investment, 0 salvage value, estimated lifespan, earnings from the investment, minimum rate of return, find out whether the investment is worth making based on present worth method. Now, the question is, example 2, the management of a heat exchanger manufacturing firm, considering to purchase an attachment for their main machine costing 1 lakh. So, the cost is 1 lakh, this is the attachment, machine attachment. With this attachment, the firm expects to generate excess revenue of the tune of 20,000 per year. So, we see the revenue is of the tune of 20,000 per year up to the end of the useful life of the machine, which is 10 years. So, n is 10 years. The machine has a salvage value of 30,000 after the useful life. So, salvage value is 30,000 after the useful life, and if the minimum acceptable rate of return I is 15%, then try to find out using the present worth method whether I should go for this machine attachment or not. Now, we see this is the present worth already cost, this part is not present worth, I have to find out present worth because it is a annuity. Every year up to 10 years I will get revenue as 20,000 rupees, and the salvage value will be obtained at the end of 10th year. So, this has to be converted to present worth. So, if I see the timeline, so time t equal to 0, I am investing 1 lakh, and each year I am getting 20,000. Now, on this 10th year I am getting an amount of 30,000 and over and above another 20,000 of this, and this is 30,000. So, this is an annuity. To find out the present worth, I have to use the annuity formula, and for this I can directly convert it into present worth by dividing it by 1 plus I to the power n. So, let us solve it. So, present worth attachment is equal to rupees 1 lakh present worth of revenue is equal to 20,000 multiplied by 1 minus 1 plus I to the power n, that is 10 divided by I. This comes out to be 20,000 into 5.0187687 comes out to be 3725. Now, present worth of salvage value rupees 30,000 is equal to 30,000 divided by 1 plus I to the power 10. It comes out to be 7415.54. So, what I get is thus net present value is called, what I am getting is this plus this. So, 100,375.3725 plus 7415.54, and what I am spending is this. So, net present worth for this is rupees 7790.91. Net present worth is positive, and hence I can go for a purchase. Now, the equipment should be purchased, the analysis is equipment should be purchased as the net present value is positive. The positive net present value ensures that a rate of return that is higher than the minimum acceptable rate of return required by management, that is 15% in the present case, can be achieved. That means, a higher rate of return can be achieved than specified as 15%. And if actually you see, a further analysis shows, that the net present value will be 0 at maximum rate of return is equal to 16.851%. That means, this investment can achieve 16.851% return in place of 15% return. Hence, this is acceptable. Now, let us go for third example. The objective is, given the capital investment, different salvage values, different estimated lifespans, different cash outflows due to operating cost, different cash inflows due to earnings from the investment, minimum acceptable rate of return, compare two different investments based on present worth method to take a decision for the investment. Now, this is the problem. This is example 3. Now, we have machine A, machine B. Now, capital investment is 45,000, this is 30,000, useful life N is 15, 10, note this is different, salvage value 5,000, 2,500, operating cost 8,000, 15,000, annual earnings 10,000, 9,000, and minimum acceptable rate of return I is 10%. So, we have to compare these two investments, that is machine A and machine B, and based on the present worth method tell which machine I should purchase. Now, we see here that the n values are different. In this problem, salvage value of the machine are positive. It should be noted that salvage values and earnings should be deducted from the present worth of the machine, because these are earnings, to find the net present worth. Further, as the estimated service life of both the machines are different, the net present worth method cannot be applied, as it needs equal time window for comparison. Now, if it is so, then I cannot apply this net present worth method. So, I have to find out a way how to do it. To circumvent this problem, in such cases a common time window, which is the least common multiple of service lives, is taken. In the present case, least common multiple of 15 and 10 is 30 years of useful life, and hence 30 years of useful life is considered for the above problem. Now, if you see this time window, then machine A will be renewed once because it is 15 years. I have purchased the machine A at t equal to 0. After 15 years I will get a salvage value of that machine, and after 15 years what I purchase goes up to 30 years. But there will be 2 renewals for machine B. It is first on 10th year and second on 20th year. So, this we have to keep in mind. So, let us go for the solution. Now, machine A, now the present worth is equal to 45,000, because 45,000 will be spent at t equal to 0, that is initially, and hence we do not have to find out the present worth of this, it is itself present worth. Present worth of salvage values so one salvage value will be received at the end of 15th year, and the other at the end of 30th year. How? If I see the timeline t equal to 0, I have taken a span of 30 years. So, here on 15th year I will get a salvage values is called SV1, and 30th I will get another salvage value, this is SV2 for machine A, whereas for machine B I will have 3 salvage values. So, these 2 salvage values has to be converted into present worth. So, this will be equal to salvage value is 5,000. So, 5,000 divided by 1 plus I to the power 15 plus 5,000 divided by 1 plus I to the power 30. So, this is to convert this salvage value to t equal to 0, and this one is to convert this salvage value to present t equal to 0 line. Now, this comes out to be 1196.96 and this is rupees 286.543. Total comes out to be rupees 1483.50. I should remember that this is earning. This is earning, and now the present worth of earning. See, this is annual earning is 10,000. I have to find out the present worth of this. Now, present worth of salvage is equal to 1483.50. What I have to do, I have to find out the present worth of this 8,000. This is the annuity, because operating cost is per year. This is earning is also per year. So, these are 2 are annuities. I have to find out the present worth of this. So, present worth of operating cost is equal to and this is for 30 years, because time window I have taken to be 30 years, is equal to 8,000 into 1 minus 1 plus I to the power minus 30 divided by I, and this comes out to be 75415.32. Similarly, present worth of earnings, annual earnings, is equal to 10,000 into this one 1 minus 1 plus I to the power minus 30 divided by I. This comes out to be rupees 94,269.14. Now, if I find out the net positive worth, net present worth, this is 45,000 plus 75415 minus 1483.50 minus 94,269.14, and this comes out to be rupees 24,662.36. Now, this is a expenditure, this is a expenditure, this is a earning, and this is a earning. So, earnings are in negative and expenditures are in positive. So, this is my net present worth. So, I can write down here net present worth $24,662.36. Similarly, if I calculate for machine B, the salvage value will be 10 SB1, 20 SB2 and 30 SB3. There will be 3 salvage values for machine B. So, present worth for B is 30,000, because at t equal to 0 I will spend this 30,000. Now, present worth of salvage values is equal to 2,500 divided by 1 plus I to the power 10 plus 2,500 divided by 1 plus I to the power 20 plus 2,500 divided by 1 plus I to the power 30. Now, this is for this salvage value, this is for this salvage value, and this is for this salvage value. Now, the amounts are rupees 963.85 plus rupees 371.61 plus rupees 143.27, and this comes out to be rupees 1478.73. So, present worth of salvage values is equal to 1478.73. Now, present worth of operating cost, present worth of operating cost for 30 years is equal to 15,000 into 1 minus I divided by I. This comes out to be 141403.72. Now, present worth of annual earnings is equal to 9,000, that's 9,000, 1 minus 1 plus I to the plus minus 30 divided by I comes out to be rupees 84842.23. Now, net positive worth for B is equal to 30,000 plus 141,403.72 minus 1478.73 minus 84842.23. This comes out to be rupees 85082.76. So, this is 85082.76. The present worth of machine A is minimum, thus it is selected in comparison to machine B. Summary: obviously, in this lecture we have taken the present worth method for comparison of two exclusive alternatives, and we have demonstrated through two numericals how this can be used. The last numerical was little bit complex, and we can see that handling the last example, that is example 3, was little bit tedious because the lifespan of both the alternatives were not the same. So, present worth method is little bit tedious to apply. This we can conclude. Thank you.